Who's the teacher?
Using Faraday's constant, the current, the reduction, half reaction, and time, we can calculate the theoretical amount of moles of hydrogen gas. Additionally, using the ideal gas law, we can calculate the experimental value of the moles of hydrogen gas.
Always put on safety goggles in the lab. You might need to use a wire cutter. Be sure not to kill yourself, okay? Good job.
For this lab, you will need 2 beakers, ring stand, burette clamp, a burette, 3 wires, 2 of which have alligator clips on them, 2 wires with stripped ends, a wire cutter in case these mess up, an ammeter, some sulfuric acid, a graduated cylinder for measuring that out, a timer, and a thermometer. So you'll find the acid in your hood. You want to pour that into a beaker and then measure out 10 milliliters of that. At 200 milliliters of water, measuring it out in your beaker. And then you want to add acid to an empty beaker and then add the water into that beaker to dilute the acid. And after that, you want to pour the dilute acid into your burette. So you want to take one of your wires and put it in the top of the burette there. Then you want to take your burette and invert it, being careful not to spill that much acid in the process, like that. And now you want to clamp your burette to hold it in place. Make sure that the other end of the wire is above the liquid level in the beaker. And make sure that that thing is closed. You can just follow the diagram given in your lab sheet to set up the system. Take one of your wires with alligator clips and connect it to that wire that's hanging out of the beaker there. And connect the other end of that to the one port on your ammeter. Now you take another one of the wires without alligator clips and put it in the beaker. Again, making sure the other end of it is above the liquid level of the beaker. Now you take another one of your alligator clip wires and attach it there. And you want to attach the other end of that wire to the positive port on the power panel. Like so. Now you take your gray wire and you plug one end of it into the negative port of the ammeter and the other end into the negative port on your power panel. Like so. Awesome. Is my lab setup correct?
Let's see. It's good.
Once your lab setup has been approved, you want to turn it on to check if it's all working. So, to turn it on, go over here, and you turn this dial to 0.5-40 volts DC. And you want to see the bubbles come out of the burette and the ammeter to have a reading. So, if that's not working, then you want to check the ends of your wires in case you need to use the wire stripper on them. And you also want to check these reset buttons to see that all of them have been pushed in. Once you've done that and it's all working, you're ready to collect data. To conduct a trial, first you want to record the initial liquid level of the liquid in the burette. Write that value down in your notebook. Next, you want to obtain a timer. And to start the trial, you want to turn on your power station and start the timer at the same time, like this. Now, bubbles should be appearing in your burette, and the ammeter should be reading something. Throughout the trial, you want to collect about 10 to 15 milliliters of gas in the burette, and you want to get an approximate average reading of the current from the ammeter. If the current fluctuates, you'll need to average the values and get an approximation. Now, once you're finished with the trial, you want to turn off the power station and stop your stopwatch at the same time, like this. Now you record the final burette volume. Write that value down in your notebook. Next, you want to take a thermometer and record the temperature of the solution.
Samples of solid PbNO3 lead nitrate. And
Repeat these steps for a second trial.
Do the calculations. Good luck!